So good afternoon or good morning, depending wherever you are based across the globe. And a very warm welcome to the second edition of the FIWARE Energy Day. My name is Gianluca Dianese. I'm the Vice Chairman of the FIWARE Foundation Energy Mission Support Committee. And I'm also the Director of the IDEASFORUM Innovation Hub, one of the FIWARE Rahe hub located in Germany. Once again, I would like to thank you for joining us today. Now, before we kickstart the event, some housekeeping rules. I assume you're used to them. Please, with the exception of the speakers, we kindly ask all attendees to stay on mute and possibly also turn off cameras just to avoid connectivity issues. Secondly, just to let you know, the event will be recorded and made available on the FIWARE YouTube channel in the next few days. So you will be able to revisit the key highlights of what we will be covering today. And lastly, in case you have pressing questions for the speakers, just drop them in the chat, and then we will do our best to address as many of them during the Q&A sessions. If not, try to respond to them maybe one-to-one in the future. So moving on. I just wanted to say a few words for the one of you who are not familiar with us. The FIWARE Foundation is a non-profit organization that drives the definition and encourages the adoption of open standards, always implemented using and leveraging on open source technologies. And we aim to ease and support the development of smart digital solutions in multiple domains, smart cities, industry, water, and so on. But as the title of the event of today suggests, today we are focusing on energy. And for the last few years, the FIWARE Foundation has been supporting local energy communities, utilities, energy service providers in trying to pursue innovation. And today, with the second edition of the FIWARE Energy Day, FIWARE is aiming at presenting a program that is featuring world-renowned speakers and experts. And we hope also we will be able to showcase a series of exciting case studies to help demonstrating how easily local energy communities can develop and integrate new, innovative, and compelling services in the grid. So let me just give you some information and introduce our fantastic speaker lineup for today. Just quoting their names because we will learn something more about them later. So we have Dr. Christian Jacobsson from Fortum, Dr. Shuli Goodman from the Linux Foundation for Energy, Trbovich, Dr. Anna Trbovich from Grid Singularity and the Energy Foundation, Professor Antonello Monti, that is the chair of the Smart Energy Mission Support Committee at FIWARE, and professor at the RWTH University in Aachen, plus a number of other titles that I will not be quoting. Then we have Professor Ulrike Rahe from the Chalmers University of Technology in Sweden, Hans-Peter Knaust from Engineering DSSH GmbH in Germany, Professor Josep Guerrero from the Center for Research on Microgrids in Denmark, and last but not least, our own Christina Brandstetter, the Chief Marketing Officer of the FIWARE Foundation. And in addition to our speakers, just a quick thank you also to our media partners, Business Reporter, Citizens Forum, Compass List, Our Future Water, and Zoom Global Cities. And just to conclude, I briefly mentioned his name already, but I would like now to formally introduce all of you to the person who will be guiding us through today's event, Dr. Christian Jacobsson. Christian and I go back a long ways since we have been working together at Alpic and then in several other projects. In March of 2020, so last year, Christian was appointed to lead the data science and analytics unit at Fortum. The key task of his unit is strengthening Fortum's projects in digitizing energy services and also supporting Fortum in reaching a vision of future energy trading and asset optimization. Christian, prior to joining Fortum, worked as head of energy and artificial intelligence at Alpic Digital in Switzerland, as head of analysis for advanced energy trading GmbH, and also as head of software development pricing at E.ON Energy Trading. I now hand it over the mic to you, Christian. Stage is yours.
Thank you very much, Gianluca. So I have gotten the role to try to guide you through today's sessions. I will do my best. There's a lot of technology and I have a lot of screens in front of me, so wish me luck on that. Let's start by sharing the screen here. I have been given a few minutes to state my case and set the stage. I hope you can see what I'm seeing in front of me. This is the climate clock. And what the climate clock is saying is that we have roughly 10 years to make our world sustainable from a CO2 emission perspective. If we continue as is, there is no simple solution left to avoid dramatic and devastating damage to our environment and living conditions. It is, of course, a lot easier to prevent CO2 from entering the atmosphere than it is to get it out again. So we have 10 years. And who's to blame for the CO2 emission? Well, energy is the #1 perpetrator responsible for more than 80% of the emission. Changing the way electricity is generated and provided to society is clearly where you can make a difference. We have commitments by countries and governments, binding commitments even as the Paris agreements, that led to massive investments in green production. We know that by 2030, we're going to have some 3 times more green power capacity than today, mainly as wind and solar. We also have electrification happening, cars becoming electric, and heating of houses using heat pumps. This will double the need of electricity. So this is quite a dramatic change, and it has a name. It's called the energy transition. In 2019, for the first time, Germany reached a milestone, having 50% of the electricity being green. 40% of this green energy came from private households and small and medium-sized enterprises, with some 1.8 million PVs on household roofs. This means that the biggest power producer in Germany today is the common citizen. This sort of turns everything upside down. We no longer only have a few big controllable coal and gas units at the high voltage end of the grid, providing power to passive consumers at the edge of the grid. We now have many small distributed sources of energy at the edge, wind and solar parks, as well as PVs on rooftops, storage capacity in batteries, demand response in industry. It is turned upside down. And most of the activity is now at at the edge of the grid, provided by prosumers, so those who both consume and prosume. It is therefore time to make sure that these prosumers of electricity, big or small, can participate on equal basis in the system of providing power to people, or actually power by people. It is democratization of energy. And local energy communities is one way to achieve this. A local energy community is mainly a legal framework enabling the prosumers to participate, but it is also creating a possibility to utilize this production at the edge, the available flexibility and the storage capacity of a community to stabilize the grid. And this can be achieved with what we call energy orchestration, a piece of technology that connects to all the devices and optimally utilizes their various features to fulfill objectives and constraints that help keeping the grid stable. So local energy communities equipped with energy orchestration is what we see as the missing piece to enable a fully sustainable green energy society. And at Fortum, where I work, we have this statement: 2020s is the decade of electricity. And there's a lot of truth in that. So I think by this, I've been able to set the stage. And I'm now going to move over to our keynote speech we're going to have. And we're going to start with Dr. Shuli Goodman. Shuli Goodman is a founder and executive director at Linux Energy Foundation, supporting open source innovations for the energy and electricity sectors. Shuli has a Ph.D. in organizational systems and sustainability from Saybrook University, with a focus on innovation and the energy transition. Her goal is to inspire, train, and enable 10,000 developers in the next 10 years to digitally transform the world's power systems. The title of her speech is Moving at the Speed of Technology. So, Dr. Shuli Goodman, the stage is yours.
Thank you. That was great. Part of what was really remarkable about it is how much alignment I think that there is between how we are all thinking. And I think that that's really a great way to start. I just dropped the slides into the window. I want to thank Ulrike, who reached out to me very, very early in the LF Energy. I think it was even before we had a name. I don't remember. Wanho, who just is incredibly important and present in the LF Energy community, Alberto, and Gianluca. And I think that the four of you have been wonderful actors in terms of enabling LF Energy. And so I start this talk by recognizing that we are two different foundations, and yet we must find the power of together. And so I love this talk because I think that a lot of LF Energy has been up at the TSO and the DSO level, but that what you all are talking about is where I believe the future is. So at the heart of the energy transition is democratization. It's moving from centralized to distributed. And within that, you know, my PhD really is in innovation diffusion. How I see that is that we have this opportunity to actually shift the concentrations of wealth from a few to the means of production and energy and power to the many. And at the heart of that is going to be local energy communities. And so I really thank you very much for organizing this conference. It's perfect. So I just threw this slide in. It's from another presentation, but when you were talking, I realized this slide for me is really reflective of, I think, the heart of what we are facing, which is that for all time, how much money there was, what the world GDP was, our CO2 emissions, and our fossil fuel consumption were pretty much at zero. And then all of a sudden you see around 1850, this kind of diffusion curve that begins to point upwards. And why I feel like, you know, I look at this and I'm like, oh my, you can really see the complexity of the problem that's facing us. Because if you just remove sources of energy, you know, you would crash the economy. So we have a very important process, but at the heart of it is the democratization of energy and power. And I would offer that it's the democratization of energy and power at all levels, whether it's social levels or political levels or energy levels and or, you know, power system levels. So I think it's a very ambitious endeavor we have for the next 10 years. And I agree, we only have 10 years. So at the heart, this is what LF Energy is. Really, it is leveraging the Linux Foundation to build the 21st century kind of action around decarbonization using open source and reference architectures and a set of complementary projects. These are members. FIWARE member and has been since the very beginning, and I thank you very much for your participation. We were founded really by RTE. They came to us and they said, we want to go to open source, and that's the direction that we want to go. I know there are many other people on this call, like Anto, so I thank you all for your participation and your support in LF Energy. So what is the Linux Foundation? At the heart, it is governance, and it is really that simple. You know, open source is really a permissive IP license that enables joint investment. But at the heart of that is a lightweight legal framework that guides over 450 projects. And, you know, for the last 16 years, we have been building projects, and all the projects that you see at the bottom, it says 350, but they're actually 425 now. That what you see are all of the parts that are actually going to create the energy transition. And so when you think about how we're going to do this, we need cloud native, we need microservices, we need 5G, we need edge, we need encryption, we need the ability to integrate legacy, you know, through containers with new microservices, and we need security. So at its heart, I believe that the Linux Foundation provides a home for the energy transition and the decarbonization of our economies at all levels. So this is kind of the basic stats. I'm going to move through this quite quickly. You can come back and look at it because there's some things I actually want to talk about before I get off. So we look at it that there's really an 80-20 rule, and our job is not to cannibalize markets or businesses. We don't want to make the work of our suppliers and vendors go away. We want to more efficiently allocate the effort. And we believe that by using a leveraged development model within an ecosystem, that we can compete on products and services, but have this open source ecosystem underneath it. At the heart of what the Linux Foundation is, aside from governance and and kind of a legal structure, is, you know, really a community of support, of marketing, of training, talent, security, compliance, badging. It's a shared services organization. So what I really see us doing is taking people, communities beyond black boxes, so that we actually have an infrastructure that can grow and scale and be composed, because all energy is local, and that's why local energy communities are so essential. All energy is local. The energy, I just came from talking to Czechs in Czechoslovakia. You know, they have one set of issues, RTE has another set of issues, communities in Germany have another set of issues, in India or Australia or Southeast Asia, they're all different, but there are some things that are similar. And what we want to be able to do is provide the Lego blocks that compose those things. And in that way, I think that our partnership with FIWARE is important. So want to talk quickly. These are our projects. Please go to our website. You can see a page on every single one of these projects. And there you can see the code, you can get insights. One of the things that we have is something called LFX. It has all of the insights about the projects. Really, our job is to provide infrastructure that enables scaling. And then there are 3 new projects. We don't have the logos. They're going to be launched soon. And one of them is one of Dr. Monti's projects, Swanyo, which was a Horizon 2020 project. Fledge Power, which is a multi-protocol gateway omnibus that is taking Fledge, which is an industrial IoT, and applying energy and connectivity to 61850, and HIFI, which I think for energy communities will be really important. And HIFI is a microgrid. Right now it's a DC microgrid that enables peer-to-peer trading. We conceive of this as a set of microservices, and so we are in an architectural sprint right now for the next 7 weeks. The meeting is not at a great time for Europe, but if you are interested, please reach out to me and we'll try and figure out how to either alternate back and forth between North America and Europe and North America and Asia. But what we're doing is really architecting the singular node, the thing that sits behind the meter, and then how do we actually take the microservices within this microgrid to be able to orchestrate energy amongst communities. So the future is shared energy innovation. This is kind of where we all started. At the head of this is power. Right behind that is cars, buildings, and trucks. So what we do in the next 10 years is going to affect everything that is all the way downstream, because we have to transform power systems. But you know what? This is what it looks like. This is a log jam, and we don't have a lot of log jams on the planet anymore because we actually have logged so much, and in a way that we don't have this kind of phenomena. But back in the day when we did have log jams, there was this idea that you actually cannot pick apart a log jam. And for me, the log jam is between the regulators, the OEMs, the utilities, you know, the major energy users, that are just kind of making it absolutely impossible to get the river to flow. And so what I see that, you know, LF Energy is doing and that FIWARE is doing is we're actually trying to blow it up, because the only way that you get a log jam to move is with dynamite. And from my perspective, the dynamite here is that the grid of the future will not be a grid at all. And we have to start talking about this. And the reason why I say that the grid of the future is not a grid is that, you know, grids are 90-degree angles. And I think that the folks that helped design the grid, you know, in the last 130 years, you know, had good intentions and they were working with what they had. But now that we actually have a moment to rethink the direction that we're going in and to deal with the externalities, I think really the grid of the future is much closer to the underlying infrastructure of a forest. And I think that that probably, for a lot of technologists, they have no idea what I'm talking about. But I really invite you to explore this idea, because underneath a forest is a complex communication network that has been developing the wisdom of forests for 5 billion years. And that communication network does some very simple things, because the grid of the future will probably be coordinated, you know, from a kind of price-based grid coordination. And there are really only 2 other variables that a device needs to know about, and that is availability and demand. And so if you were to look at those 3 things, those are actually what underlies the forest. And so I'm really asking people to look at this. I'm seeing that there's a question. there's a video that I will pop in there, and you can go take a look at it. I'm very influenced by the work of Suzanne Simard, who's a forestry person from British Columbia. There was a great article in the New York Times. There's a wonderful presentation by BBC called the Wood Wide Web that really talks about the communication networks underneath forests. And what makes it important is because it is orchestrating an ecosystem, and local energy communities are really ecosystems. So the next kind of hypothesis that I have is that the future is not given, meaning that it is our thoughts, our words, our deeds, our actions that create the future. But the importance of this, and this is a picture, very close-up picture of squash in my garden, is that if we want to grow the seeds of the future, we can't plant them in the garden of the past. And I think that this is an important thing to understand about how the future emerges. You have to protect it because there is a need for homeostasis that the dominant paradigm is going to keep asserting over and over again that will co-opt the future. And if we really want something different than what we have right now, we need to protect that future. And so LF Energy, FIWARE, these are communities that actually can support the evolution of a future that is free from fossil fuel and that enables decarbonization. And then finally, I'm gonna end with this and then kind of run through just quickly a couple of things. But resilience is key to our future, both the grid, our communities, and ourselves personally. And this is a message really that I have to everyone, and it's that this is kind of my avatar. In 2020 was really hard. 2021 has not been much better, to be perfectly honest. It's been pretty intense over here. But 2020 was a pandemic, a crazy president, a political scene that was really horrible, an insurrection, and I had fires 5 miles from my house for nearly 3 months. I also had teams dealing with hurricanes and tornadoes, and I really came to understand something about the fog of war, which is that uncertainty is going to abound. Information is going to be asymmetrical. We have 10 years, and one of the things that we can do best for each other is actually figure out how to support, love, be kind to each other, because we have to carry on regardless of the outside circumstances, and we have to figure out how to support each other. So I really encourage everyone to find your avatar, figure out how to get strong, and to really recognize that personal resilience, community resilience, family resilience, and the resilience of what we're doing is going to be critical. So I think I'm probably, am I at the end here? Can I run through 3 quick slides?
Yes.
Okay, so we're building a grid that's beyond our ability to manage. We need to 50% of this effort is going to be digital. This is a number that actually came from EnergyNet, and it aligns with actually what happened in telecommunications. Telecommunications industry recognized that 75% of their digitalization effort was going to virtualize their hardware and software. I think that's probably 50% for us. That's that underlying HIFI, that underlying communication network under the forest. 80% of the software will be open source, and 40% of that effort for decarbonization is going to be open source. So it is with FIWARE, the Energy Web Foundation, the Linux Foundation. We are all in this together, and I really am committed. Even if it's difficult or challenging, I am truly committed to figuring out how to work together, because how we do this together is really going to be important. I want to just show one slide here, which is we have a spring summit. We are looking for cost papers. It's open. Go to our website. The slides are having a hard time updating. There they are. It's on April 14th. We would love to have presentations from you all. The call for papers are due on February 8th, so there's less than 2 weeks. Please join us. And I will end there. And I agree, mycelium is the dynamite.
Thank you very much, Dr. Shuli. As a moderator, I'm also the police in time management here.
Yes, so, of course.
I think we should have one question brought in here despite the time. And when we talk about open source standardization, I see as one of the main reasons for open source is to create a standard which will allow for many to contribute to solutions. Do you agree to that, or am I sort of interpreting this wrongly?
So we typically actually, so we see standards and code as two separate things. And what we've discovered at the Linux Foundation, I mean, we do have standardization efforts. We have an ability to actually move from a standard into ISO using the Joint Development Foundation, which is part of the Linux Foundation. But while our software is based on standards, we really believe that actually going to code and building the de facto kind of expression of it and then contributing back upstream to the standard is more efficient. And so there is more of a decoupling in terms of standards efforts. And I think standards efforts can get you going in circles as opposed to really going directly to code. And so the Linux Foundation is a code first organization. And so I agree, but there's a little bit of a but and.
Okay, I see. Also another question here. If people want to participate and support in this work of creating this open source code, what is the entrance?
So if you go to our website, there's a community page and you can see access to our working groups, you can see access to our projects. All of our projects are open. Our calendar is on the website. It's also on our wiki. You can join any community. You can go to any of the technical steering committees. You can go to the technical advisory council, which is all of the projects. You really jump in. Again, it's a code first organization, and where we really want to focus our efforts is on code. And on the wiki is a process for submitting code. I am not the determiner. I have to tell people that frequently. I do this. I try and make sure that we're healthy. I'm more the gardener. But you guys have the opportunity to come and plant whatever you want in this garden. And my job will be to make sure that it stays healthy and bug free.
I really like your metaphors. Thank you very much, Dr. Shuli. So
thank you, Christian. It's been a pleasure.
Let's try to move on here. We have as a next speaker, Dr. Anna Trbovich. She's a co-founder and CEO at Grid Singularity, developing grid-aware peer-to-peer energy exchanges. She's also co-founder and vice chair of the Energy Web Foundation, focusing on accelerating the blockchain technology in the energy sector. And as if that was not enough, she also serves on the advisory board of the United Nations Economic Commission for Europe on carbon neutrality, and also at the German Energy Agency's advisory board, offering support to startups with a focus on the energy transition. Anna holds a Ph.D. in public international law, negotiation and conflict resolution. She will give a talk with the title Social Energy Network. So please, Anna, the stage is yours.
Thank you, and thank you for the invitation. First, hello to many friends. Many thanks to the FIWARE Foundation Just as a disclosure, we are a company, a startup, but we're really more of a social entrepreneur. And we develop our software open source. And what I wanted to share today is how we aim to engage to arrive to this future where local energy communities are empowered to trade internally and to have more rights, such as knowing the source of their energy and having a choice of who they can trade with. So we can go to the next slide. What you see here is the structure of a hackathon that we led last year in November of 2020, together with some significant energy corporates, including 3 Dutch DSOs, Stedin, Alliander, and Enpuls, and 2 large corporates, Engie and E.ON. We created a challenge that had 2 streams. One was about grid operators interacting with energy communities. And also the goal was to encourage third-party service providers to develop smart trading strategies for energy assets that participate in local trading. And the second was about what could the future app look like for an end user that is really taking the next step to create what becomes a social energy network. And on the next slide, you will see the essence of this setup, where what we do as a company is in the middle. In the middle is the exchange. We are an exchange operator, open source exchange operator. We connect on one hand with the grid operators. You see the API on the left-hand side, and on the right-hand side with the aggregators and management service providers that reach the end user. And what we're trying to encourage is full interoperability, open standards, and lots of competition in the market to improve services for the customer. And what we did that you will see on the next slide is that we virtually connected a community. So it was real-time data stream. The transactions were simulated. There was no financial exchange, but it was virtual, real-time, local energy market in action. And one of the participants was kind enough to show how their energy use peaks as tea is being brewed. So we saw all of that live, and we also witnessed how when you have smart, intelligent agents, your resources that you have can be even more optimally used locally. And then, and this is what you will see on the next slide, the focus of the second stream, and this is what I really want to present today, was about how to engage the individual. Because we truly believe that the individual is critical for us to reach the goals of the energy transition. And it was an event that included energy experts, civic activists, students, and one of the key energy researchers, Mike Fell from UCL, was kind to explain how important it is to think about social fairness when you design an app. And he gave the example of Airbnb, where it was found that the app, as interactive and peer-to-peer as it is, ends up discriminating a certain group. And this was something to be avoided as you create peer-to-peer energy apps. We had 4 teams that brainstormed over a weekend how an app could look like. 2 were startups. One was a student team from a graduate program of Energy. And one was a small group from our company that was there really to guide and support the process. And they came up with some very interesting solutions that I would like to share with you, and then hopefully incite a discussion about what we can do together next. So we can go to the first one. The first one said, "Get amped," which I thought was a very, very interesting slogan. And it basically said that you know, you should use your energy to support your artist, your football club, and you know, as we brainstormed in the discussion, we talked about not only financial support from your savings, but also directly you know, ensuring that they are supplied, and different ways to interact with this app. And this group, this team, felt that to engage an individual, you have to start with their passion, and they wanted to focus on the artists as a first group. Then the second team, as you will see on the next slide, is a team that said that everyone has their Carby, and this is a planet that they're nurturing, and you're taking care of your planet through your behavior and adjusting your behavior. In that sense, you know, it is going from what we already have in many other so-called home management apps. The difference is that they are trying to reach out and also build a community where you can include your friends and neighbors in this planet that they call Carby. And then the team from Grid Singularity proposed an app called Saft, or actually Saft in German, meaning juice, to stir your juice, to you know, again, stir your passion. And it was about energy clubs. And those clubs would be formed in a way that your social network is formed through different apps that are social apps, social engagement apps. And again, this could be just friendly, wanting to trade with friends close by. It could also have a social component, meaning that you include a local hospital and you say, I want to buy from their generator first, and then move next to another source of energy. And then finally, the student team, which is the next presentation, Decergy, so like decentralized energy, they proposed an app called Lit, and to lit people up. And I found this very interesting in that they saw energy as in what it can do. So rather than say you're sharing kilowatt hours, you're actually sharing a quantity that you need to bake a pie or to take a shower, and you make that as a gift or you exchange with someone else. So trying to represent what energy does and then exchanging that representation. And it was a wonderful student team that came up with this proposal. So what were the conclusions in the end? We concluded that the energy is not boring, does not need to be boring. We concluded that it can be a social instrument used to support social inclusion, public health, a charity of your choice, an artist, and definitely that a collaborative approach was needed, because if we go back to one of the first slides I presented, one requires the grid operator to be involved, one requires an end user app provider to be involved, and then use these freedoms, degrees of freedom that we called and that we enabled for this local exchange to provide a different, more individualized service to the customer, where the customer can be a very active participant in this market. And again, making sure to ensure fairness as you're designing this new way of exchanging energy. We also strongly felt that we still need to educate users, to motivate them to go towards this investment, which is why we have a free to use open source simulation of an energy market where anyone can create their own energy community and see the benefits. How does it impact your energy bill? How does it impact the self-sufficiency of your community? And we will move forward to create an even more user-friendly interface to really promote that education. And these different apps have been described in an article on our Medium blog, because just like we publish our code, we also publish all of our thoughts, ideas in our Medium blog. So really fully in line with the open source culture at the company. I will here end my presentation so that we have time for questions, which I'm really interested to hear.
Thank you very much, Dr. Anna. We have a question here. You're talking about energy exchange and that the grid Singularity is sort of supporting a solution for what we call the prosumers in the beginning to exchange energy. Do you see any legal constraints in making this happening? Are the legal framework for a local energy community enough, or do you see that we need to have better support on having proper rules in place to make this possible, even on a larger scale?
We have a very encouraging directive from the EU that was adopted last year. 2 directives, in fact. We also wrote an article about that and how they promote energy communities. And the devil is in the details, of course. It is how much freedom will the EU member states allow? So one question that was posed earlier by Natalie is, does it matter if you are a citizen energy community or renewable energy community? If you read these definitions in the text, it does not, and it leaves sufficient freedom that you can organize that community in any way you want, basically following many of the paths that were chosen by the teams that had this vision of a future energy app for end users. And some countries will be leaders, others will be more skeptical. But if you just read the EU directive, you can literally say that a large city in Europe is also an energy community if you want that to be the case and if you want to allow local energy trading. And what will make regulators happy is more simulation studies, of which we have done several and others have as well, showing the benefits. And also we need to jointly think about how to resolve the balancing compliance regulation, because currently it is not illegal to implement peer-to-peer trading, but the barriers are very high for small players, basically for those that are not large energy traders.
Exactly, I agree completely, and it's going to be very interesting to see what how the roles might change for the district system operators, for instance. Thank you very much, Dr. Anna. Trying to keep time schedule in order as well. It is now time for Professor Antonello Monti. Antonello Monti, he has a Ph.D. in electrical engineering from Politecnico di Milano, and he spent 8 years as a professor of exactly electrical engineering at the University of South Carolina. Today, Professor Monti is the Institute Director for Automation of Complex Power Systems at the University RWTH in Aachen. with a focus on fundamental and applied research in digitalization of energy systems. Professor Monti is the chairman of the FIWARE Smart Energy Mission Support Committee. And he will talk about FIWARE Insights. So please, Monti, the stage is yours.
Thank you, Kristen, and good afternoon, everybody. It's my pleasure to be here this evening. And yeah, I want to talk about the role of FIWARE in how that integrates in a larger picture at European level. Particularly, the FIWARE Foundation is also part of a European project called OpenGI, in which the challenge of creating this large level of interoperability is one of the key missions. And I would like to give an idea of what that challenge is, and then to understand the different aspects and how FIWARE fits in these different challenges. Oops, PowerPoint. Okay, so we have been talking about the changes that is going on. I think in Europe, since we have a Green Deal, we have a clear direction that has been put in terms of law, which has been really a revolution that happened quite recently, putting the agenda of environment in a completely different perspective. And this is coming into the energy sector as a change in a change. That's the way I like to put it. So while the energy system is trying to get more modern thanks to digitalization, is also revolutionizing. We heard about democratization concept, this flipping the system 180 degrees, which is one of the key challenges that we are facing. And as we heard in the previous presentation also, it's not just a technical, but this is a social element, not only economics, but really social, because the players are changing. The elements of fairness we heard before are a key element. And then we have to think from a point of view of digitalization without challenges. We need a lot of different things to agree, and to agree at European level, if you talk about the energy systems where we are immersed, at least for us living here. And that starts with data models. I know also in the Linux Foundation, there is a lot of discussion about it. I think electrical engineers have been working with that mentality for a long time, so that there are a lot of international standards from which we can start. But I will show you later, that's only if I limit strictly to the electricity sector. We need to work on architectures, and this is one of the key tasks that is still running. We had a lot of work done in many projects I'm referring as usual to Horizon 2020 project for the European Commission scenario. There are a lot of ideas, but still don't fit all the pieces together. We were talking about this Lego concept. We don't build the full wall yet. We need business models. We heard about the challenges. We want to involve citizens. We want to make a more democratic systems, but the real scenarios to make it possible is still not there. We would talk about digitalization. Governance still is to be developed, but critical is to reach the target that we heard and think about what Kristen presented at the very beginning. Electricity systems, even being the center, will not make it alone. And the sector coupling is critical. And then when we go back to the data models, we realize that enlarging what it means managing data becomes a new challenge. And that's exactly what is behind projects like OpenGI, to cross between electricity and other sectors so that we are not limited in our vision. But if we just stay in the electricity, we can see the challenge is still open and large. If I look at the electricity, there are three key levels: the customer level, which is supposed to become the most important, the coordination locally through the distribution system operator, and the transmission system operator. We come from a system with everything was under the control of the TSO, while the other were in a sort of passive mode. And we want to come to this logic, like Kristen said, of orchestration, where everybody starting from the bottom is part of this system. Building this chain of data exchange and data interoperability is a huge challenge. And there are a lot of activities. The TSOs are large and structured thanks to NTSOE, and in Europe have been able to really work on creating a common systems among all the states that are interconnected and synchronous with each other. But when we move down is where we have more challenges. There are currently at least 2 projects running the studies on how to manage the interaction between TSO, DSO, and customers, and the results are supposed to be available in about 1 year when those projects will be over. But that's not the end of the story. We need to particularly work at a DSO level, where the digitalization is really a revolution, because we move from passive distribution network to active distribution networks, and that's where a lot of work is still to be done. I like to mention Shuli referred to this Sonia project in the Linux Foundation. The Platone project here is kind of like the continuation, where this effort is expanded in new directions. And also, last but not least, for the reason we said, the involvement of customers is still to be brought in from the point of view of interoperability. There is a major effort going on trying to bring these things together with Project OneNet, over which I will tell you in few slides. But this just started, just to give an idea. So even believing that this project has the ambition to be the overarching umbrella, it will take 3 years before all that will be done. With the budget Christian gave us, we see that we are in big trouble. Interoperability also that's emerging is something much more complicated than just data interoperability. We need interoperability at data exchange. We need interoperability of services. This is one of the last and most important challenges, because when we want to start trading, we talk about different products. It's an interoperability at a higher level that is not just making data compatible. And here there are different things to keep in mind as prerequisite. There is a problem of data sovereignty and privacy, because we're talking about large involvement of customers. And I think here a lot of people are looking at what has been done in the industry with the Industry 4.0 activities and the International Data Space Association, which is also partnered with OpenDI. And the link again to go across sectors and to allow really a variety of products. And that's where I think FIWARE plays a key position in being the basically only one with that kind of ambition to go across domain. I mentioned the OneNet project. The OneNet project is unique in its breadth. There are 73 partners across Europe working together to define this architecture that will respond to the challenges I told you before. And what is also unique is that is involving demonstration that go all across Europe. There is a huge number of TSO and DSO and involved, so that basically every country in Europe will be affected by demonstrations. And what is new here to really open up the market is also we are looking more and more at products that can go across countries. So it's not just the classical exchange among countries at TSO level, but every possible trading should be possible if you want to allow a very fair situation. And the going across sector and brings me to the possibility again to link a lot of things together. We saw that FIWARE is basically this glue that brings the sector together. And one interesting experience we have been doing developing project is that how, thanks to that, we can bring other open standards together. So the Sonia again that was mentioned by Shuli before to define a microservice-oriented architecture for the automation of the distribution grid, deeply embedded in the electrical mentality, allows you then through a message broker to go into a FIWARE architecture and bring energy as electricity into a smart city scenario. This is a perfect example that what we're looking for is connectors that make possible data interchange so that a larger interpretation of interoperability is possible. So I tried to bring very quickly to the conclusion. I promised to be short. We're not talking about one single solution. We are talking a lot about open solution that fits perfectly with FIWARE, Linux Foundation, and talking about interconnectors that makes this possible. The goal is a digital single market in Europe. That's what, as I mentioned, the Project OneNet would like to enable, bringing all those efforts together and looking at the points of interconnection, making possible what is today not possible, even not just from a legislation perspective, which will be also an aspect, but even directly from a technical point of view, in this sense of interoperability. And last but not least, I'm electrical engineers. I love electrical networks, but the big challenge coming up, again, when we talk about interoperability, is to go beyond one sector. That's where I believe FIWARE is a cornerstone, and the context broker as an example of tool that will enable to expand beyond the limited vision of a single vertical and to go into a real open system. I thank you for your attention, and I think I was basically on time with my presentation.
We are a bit over time, Antonello, but that's okay. We have one quick question for you. There's many similarities with telecommunication backbones, and we have really powerful companies with a lot of experience like Ericsson and Nokia, used to providing this kind of network to manage data and information of huge volumes with low latencies. And they are interested in this arena of energy. How do you see that they can actually play a role, despite the fact that we need open source and we have organizations like FIWARE? Is there a match?
I think so. Well, what I can tell you is that most of my work comes from the interaction and the wonderful cooperation with Ericsson. And Sonio is a product of a project coordinated by Ericsson. So I was the technical manager, but the coordinator was Fiona Williams from Ericsson. So they understood, because as you also heard from Shuli, that what Linux Foundation is doing in energy now, they started doing it first in the telecommunication business. So I think they actually are the one that learned a lesson before we did in energy. So in that respect, they're a wonderful partner. At least this has been my experience so far.
Okay, very good. Thank you. It is time to move over to our use cases. We have 3 use cases, and the first one is going to be presented by Professor Ulrike Rahe. She's a full professor of industrial design at Chalmers University of Technology in Göteborg, Sverige, since 2003. And since 2017, she leads the Chalmers Design for Sustainability research team, focusing on EIT climate KIC. Well, what it means is a knowledge and innovation community working to accelerate the transition to a zero carbon, climate resilient society. The purpose of Ulrike's research is design for sustainability and well-being. And I picked up the following phrase from Ulrike. It is possible to improve the world and make our environment a better, more stimulating and healthier place to be. That's a pretty nice sentence. The title of her speech is The Swedish Perspective, and it's focused on human needs. Please, stage is yours, Ulrike.
Thank you, Christian. Yes, so I'm going to introduce 2 use cases to you that put the citizens in the focus, not the citizens as prosumers, but the citizens as consumers. In general, on the European level, 27% of all energy consumed is related to consumers, to end users. And as a matter of fact, a lot of them, and Anna was into that as well, are not really aware of their energy consumption and do not have any relation to that. So what we did is we rigged 2 field tests in the city of Malmö, focusing on 2 different aspects of energy consumption. And I'm going to start with a small movie that summarizes that.
The demand for energy today is high and still growing, a global challenge affecting everyone and our planet. This is why European partners Germany, Sweden and Romania in the FISMET project joined forces to co-create solutions for a smarter energy future. The platform they use is cloud-based, service-oriented and open source. giving rise to a new European standard, FIWARE. In Sweden, the project team, Chalmers University of Technology, the City of Malmö, and E.ON developed and tested new efficient and user-friendly energy services. Chalmers University of Technology developed Aero, an app that enables end users to monitor, plan, and control their energy use, affecting choices related to cost, CO2 footprint, and energy mix. Simultaneously, E.ON developed CISO, a smart platform using thermal inertia in buildings and power control for peak shaving. Through FIWARE, field tested in Malmö, the researchers can connect both end users' input and smart grid management to the energy system. As a result, in periods of high energy demand, consumption peaks can be shamed. Less peaks in the grid reduces the need for non-renewable energy sources and contribute to a more sustainable energy supply. Connecting Aero and CISO to more buildings globally would accelerate the shift towards more sustainable and smart societies. This map shows that both individuals and smart grid operation have a part to play in the creation of future sustainable and smart cities. Let's be bright together.
Oh,
the demand
no,
for energy.
sorry. Here we go. So in study 1, we actually focused specifically on the thermal perception of the user. So how experience users load shifting when they are either aware or not aware about it. So their thermal perception will definitely steer their acceptability of such interventions with the grid. So what we did is we developed also an app who does not do that today, but the app was specifically meant to collect data for our research, where we investigated how users reacted on the shifting, as I said before. And we did that in the city of Malmö, where E.ON meanwhile has connected more than 220 multi-residential buildings to their own platform CISO. And when we started, they were right in the beginning. So our base for the study was through 12 connected buildings. The study had 3 phases. We did an initial survey with the participants. We ran a 2-week trial, and during that trial we used our diary study, and we did a closing survey. And we had those 4 different test groups. Some of them were notified, excuse me, through SMS in forehand when the shifting should take place, and others were not. And we had a control group that were not exposed to shiftings at all. So as a result, we found that there were no significant differentiation in the 4 groups, but this could also be due to the fact that we had not a huge sample. We would like to repeat the study in an enormous sample, like with all the buildings if possible. Users experienced a lack of control over the heating. In the mornings were in general perceived as colder than other times of the day, and information about upcoming load shifts were very appreciated. So factors influencing users' perception and acceptance of demand-side management are, for the first, the actual indoor temperature. Is the indoor temperature bad? They will react, of course, differently. An own control over the indoor temperature is also needed. The right timing of the day. So don't do this when thermal perception is not given. And correct communication to the users. In study 2, we had a totally different approach. We developed an application this Aero application that had as a goal to study the effects of such a smart energy platform on the user's behavior and their energy consumption. In this apartment building that I showed, it was newly constructed. With 27 rental apartments, we included half of them in our study. What we did is that we connected high-consuming household appliances as the fridge freeze, the dishwasher, the washing machine, and the tumble dryer, but also the floor heating via smart plugs, because all the devices were not smart yet, and the cloud through FIWARE to our application Aero that you already saw in the movie. So we had to perform that study, an information event first. We had an initial survey with 39 participants. We were testing the Aero application through 4 weeks. Then we had a mid-study interview with 5 participants, a closing survey, and final interviews. So a multi-method approach. What we found was actually increased awareness on user side. So I have to say to Anna that I do not really agree that we can educate the users, but we can raise their awareness, which is a very important first step. So what we found out was that users were totally uninformed about variations in energy availability. They had no clue about it. They increased their awareness about their own electricity and water consumption. They increased their awareness of electricity use of specific appliances. And they realized that they were actually using more water, especially warm water, than expected. What effects did Aero have on users' behavior? Well, users reported that they were showering shorter times and lowering their temperature. They were running full dishwashers instead of half-packed dishwashers, and they were using the eco program more regularly. What effect had Aero on energy savings? So Aero contributed actually to reducing the use of the floor heating for 48% of the participants, the dryer, the tumble dryer, for 42% of the participants, and the washing machine and the dishwasher for 32% of the participants. So one quote only, if you admit, before I got this application, I had the floor heating on all the times, but then I saw the consumption and thought, that's a lot actually consumed on the floor heating. That is why I generally turned it off. What I would like to give to you as a FIWARE committed society, we experienced through our use cases a couple of challenges that I really would like you to improve. The reference data model for buildings proposed by FIWARE initially, of course, has a relatively coarse granulation, which is meant for entities on a larger scale. But we, as you got it, we need a finer granulation because we do not only go down to apartment level, but also to single appliance level. So FIWARE in general is very useful according to our experience for gathering data, but not yet designed to control smaller appliances in real time. And then a couple of you mentioned it already, but we have a specific issue with security. Security measures according to GDPR are lacking in FIWARE, which actually challenged us a lot because we're collecting user-centered data. And no option was given for coupling FIWARE to existing open source identity and access management tools, as for example, Keycloak. So inputs for further development, for future development. In Aero scenarios, information about, for instance, floors, areas, apartments, rooms, all the way down to appliances level is addressed. So this would be great to get it solved. User-centric applications require a fine-grained security layer with authentication, authorization, password management, and session management. And the device database and security in the Aero app were transferred to Tempero API in the end to solve our problems. So that was it for me. Thank you very much for listening.
Thank you very much, Ulrike. I actually grew up in Malmö and spent my first 30 years there. So if you made this study work there, it works anywhere. They have people from all over the world.
Yeah, and we'll work further on that. Thank you.
Thank you. So we're moving on to Hans-Peter Knaust, who is the Managing Director of Engineering, Digital Services and Solutions. Engineering support customers in the digitalization of business processes in the areas of smart cities, digital health, and telematics. Hans-Peter Knaust will talk about smart energy, digital solutions for a sustainable energy transition.
Yeah.
So please take it away, Hans-Peter.
Thanks a lot for your nice introduction, and really I'm happy to have the chance to introduce you one of our projects we developed in Hamburg based on a FIWARE solution. But first of all, I'm Managing Director at Engineering. Engineering is an international software developer, system integrator, and IT service provider based in Italy. We have a strong focus on sustainable development to support our customers, partners, and non-profit organizations. And our new sustainable business also needs new digital technologies, and we are supporting 6 UN Sustainability Development Goals with innovative digital solutions in energy, mobility, and transparent supply chains. In the energy market, we think the fight against climate change means the change the way to produce, transmit, and use energy. And energy does not only mean electricity, also heating is an essential building block for the energy transformation. To support our customer during this transformation, we offer several solutions with a focus on electrical and mechanical system management, remote control, lighting management, and e-mobility, but also we have a very strong focus on open source. Maybe you know that engineering was one of the first developer for the FIWARE solution, and we are part of the FIWARE Foundation Platinum as a Platinum member, and our colleagues in Italy doing amazing things for the further development of the FIWARE platform. In Germany, we have a strong focus to support local utilities, regional energy suppliers, and also on the second pillar, we are serving public administration for smart city initiatives. In our project, we have the issue, and I think Professor Monti mentions this also, to integrate a lot of legacy system. We have a flavor to support local business on district management areas. And to do so, we have to integrate, for example, SAP, we have to integrate smart meter data. We are using, of course, FIWARE also for IoT integration, but our customer also expects the integration of CID and building information models in our solution. And from the TSO and DSO sides, we have to fulfill requirements regarding operations, GeoServer, and have to integrate a lot of classical web systems. That makes the work as a system integrator very complicated. And in our solution, we think that there will no leading system at all. A new solution must be part of several solutions. We call it a system of systems approach. And in this system of systems approach, the API management, the data management is core. API management is not only data management, also included the full life cycle of the data. So in our approach, we are using, of course, FIWARE, but we have on top an API management platform who do all the conversation and data reworks. In our project, I want now to show is a district management service in Hamburg, which we developed together with the Chamber of Commerce in a district in Hamburg. This solution is a FIWARE microservice Kubernetes installation. Where we are offering solutions for energy monitoring in the facility management, also covering virtual small grids. and we try to integrate the civil society and the citizen with several participation initiatives. We think if we want to be successful in the transformation, we must be aware that the civil society, the citizen are part of the game. It's not only a technical driven discussion. Be in front of the people means to be successful. So we offering several digital services via portals and apps on our digital marketplace. We entered several value-added services also from commercial partners, for example, for weather and traffic data propose, but we are also able to integrate open data structures, which are, for example, delivered in Hamburg in the open data portal, which is very famous. We are able to bring all the portion of data together and offer there, for example, solutions for energy controlling. We can do some simulation, not only based on the measured data, also with access of real-time data in the web, and also from 3D data from the open data portal, which has a value to get a better simulation and to define proper models at all. And this, because the smart city solution must be easy to use, we defined several IoT services as a kind of a shop cart, where we defined information portions for building or shift monitoring, also for smart parking, motion detection. This is done in a shop cart modus, so the customer can use the sensors in a plug-and-play modus, that they can get self-services to integrate and modify in a specific way the given data. We doing that, of course, based on FIWARE with FIWARE technologies, but are quite open for all other transition technology, if that is 5G or the LoRa, Sigfox. The model is so open that the customer can use a lot of IoT services, which we defined in a proper way before. As mentioned, on top on this platform services, there is an API management platform. It's the same play as a smart city platform. It must be open. It must be an open platform. It must be enable the end customer to use self-services to monitor and check the different status of the data portions. So our API management platform is also open. It has, of course, some FIWARE components, but also we are able to integrate huge geodata. We are able to integrate SAP data, open data as mentioned, but the system is so open that you can also use the modern AI and ML services from the hyperscaler. If you use some from AWS or Deutsche Telekom Cloud, you can use these services to get access of new research and simulation technology. So I think it's very important that your system is open and you can in a very flexible way modify your services and data sources. At the end of the day, as mentioned, it's an data platform powered by FIWARE. We are using standard FIWARE modules for discovery, analyze, harmonization, and visualization of multi-data. We have a single point of data knowledge, and we can, in real time, management the data regarding monitoring, alerting, and decision support. So you have a high flexibility to define new services. And you can start, of course, with a FIWARE native installation. We support our customer to bring it into the specific data center based on microservices, or you can use pre-configured solutions and best practices like the digital enabler, but the customer has the freedom of choice which components he would need, he want to use in his specific environment. And I think that is the flexibility. Until now, about 30 people using this platform. we built several balances for carbon, for the carbon footprint, for energy consumption, and we have a dashboard to monitor facility if the door is open and the heat's on. What is consumption, production rate of PV, installed PV systems. We combine that and offer this on our platform. You can have an access for general data for free, but you must be registered. If you need specific access, for example, for some buildings, it's not needed that everybody knows that the door is open. But if you are the facility manager, it's needed. So we have a defined role concept in place, which help us to have a feasible system for the district in Hamburg in place. So for the first run, that was our example. We built up a district management system for civil society, for local business, and for the public administration in Hamburg, which is part of the climate change plan. Yeah. Yes, it's.
Thank you very much, Hans-Peter. I urge all the listeners, so if you have questions, put them in the chat, and I also urge all the speakers to answer those questions in the chat. Keeping the time, we have one more presentation of use case before we're going to have a panel session. So it's time for Professor Josep Guerrero. He received his Ph.D. from Technical University of Catalonia, and is now a full professor at the Department of Energy Technology at Aalborg University in Denmark. So my first question is, how do you survive the winters in Denmark? I know they are harsh. Professor Guerrero is a director at the Center of Research on Microgrids. His interests include distributed energy storage systems, energy management systems, smart metering and IoT for microgrid clusters. And the title of his speech is IoT-Enabled Microgrids from Digitalization to Decentralisation. So please, the stage is yours, Guerrero.
Thank you very much. Okay, answering the first question, yes, it's not only in Denmark very cold, but also windy. So we reached last year the impressive amount of 80% of our electricity demand was covered by renewable energies. So I think that this is a very huge impact, and I hope that also Europe will follow the same trend. Okay, I'm going to show some, let's say, platform on IoT-based microgrids. Here you have our center, which is located, by the way, in the Department of Energy Technology of Aalborg University. And we have been developed some ideas on microgrid clusters, so how we can interconnect microgrids between them and create networks. So that's, in that case, is very important also the coordination between those microgrids. The other thing is digital twins and IoT, which I'm going to present here. And the other two important clusters are also maritime microgrids. We are deploying microgrids in seaports and also shipboard power systems, which you can see, for instance, in Denmark. We have more and more electric ferries and hybrid vessels. And then not happy to just cover the Earth. Also, we are doing research and projects on space microgrids, especially microgrids placed in satellites, which are becoming huge, and also closed ecosystems. So this is some pictures of our living lab facilities. You can see we have some wind turbine here and photovoltaic panels, and then we just have a demonstration house. And inside this demonstration house, we have power electronics converters together with the communication systems, with display, and here we have all the appliances. Some of these appliances are IoT ready. for instance, this oven, and also we have also a freezer, which is also, both are IoT ready, and the others are also sent through some smart plugs, which are commanded by Zigbee. So this is our platform. This is a little bit what we have already in our lab facilities. We have around 10 kilowatt peak of rooftop panels, and then we have 5 kilowatt peak of a small wind turbine. We have also a lithium-ion battery pack from Sonnen. It's a 5 kilowatt hour, and then a methanol fuel cell system, which is provided by FIWARE Energy, 5 kilowatt also. And then we have all the power electronics converters needed, also together with underfloor heating and cooling system, electric vehicle charging station as well, and all these appliances that you can see here, washing machine, dryer, kitchen, microwave, and so on, are connected through IoT, some of them, and some others, the rest, are connected through smart plugs to the Zigbee network. So this way we can implement real-time energy control platforms, also with forecast and optimization inside. And also we have been deployed some non-intrusive monitoring systems to use just the smart meter and to avoid to have all these smart plugs around the house. So we have both technologies together to make different tests. And the first study case that we have here is the energy internet. And this project was to develop Internet of Things for smart grids, which, by the way, were also smart meters very important here. So in that case, we developed energy management systems in order to monitor and make supervisory real-time control. And then we had distributed energy resources monitoring. We had demand side data collection, and finally demand behavior forecasting also, using, thanks to this infrastructure that I mentioned about advanced smart metering, we could have real-time consumption information and also pricing. So this was the first step. And then we create here from the house and our AC and DC microgrid laboratories, we took the raw data inside this first layer, which is the FIWARE based data layer. And inside we deploy a context broker with real-time data. And then we put some of this data inside the data warehouse. So it's basically a number of database systems. And then this was interfaced with the third layer. So if you imagine this is the energy physical space, then we have the FIWARE based data layer, and then we have the service based information layer, in which we have number of energy services, and then we have also the FIWARE data layer. So here you can see how is our architecture. Basically this three-layer architecture. We have the hardware and facilities. Then we have the FIWARE-based IoT framework. You can see inside also the context broker. We have been used also the database Mongo and so on. So all these things, and together with IoT agent systems, perform this part of this IoT framework. And in the third layer, we have the upper services and the application layer, right? All these things are also connected through Grafana in order to show all our measurements and actuations. And then we have a connection to our system portal. Yeah. The second case is it's an outcome from an H2020 project, which we already finalized. And that's about open virtual neighborhood network to connect IoT infrastructures and smart objects, called also Vicinity. And in that case, Vicinity wanted to provide for what we call interoperability. In that case, decentralized interoperability. So that means that a number of sensors that are working with different protocols, they could interoperate each other to give services in energy, mobility, healthcare, and building sectors. So basically here, Vicinity operates in 2 levels. One level is more the level of network or infrastructure in order to connect proprietary IoT infrastructures. And well, this was in that case an open gateway that we developed. And then the second case, it's on the IoT device level. So in that case, we wanted to connect with standard IoT infrastructure. And then you can hear a little bit how it looks, our Vicinity scheme, in which you can see we have browser applications, 2 Vicinity nodes, and then we have IoT mobile devices and connection as well to the cloud. Right. And then we have here the future research directions. You can see that we have been also work with cybersecurity and cyber resiliency in microgrids. The second step, it's more all what I presented today, energy-aware services and data-driven innovations, together with IoT and smart homes in buildings. And right now we are also developing digital twins for microgrids, and we expect in future projects also to integrate blockchain-based peer-to-peer and energy trading for microgrids. So that's all from my presentation. Thank you very much. And thanks a lot also as well to the partners. Thank you.
Thank you very much, Josep. And it's now time for the panel session, and I will hand over the word to Professor Antonello.
Thank you, Christian. Yeah, but you should stay because you're part of the panel.
I'm staying.
Thank you. So, question, and it's open for the 3 members. So Josep, Peter, and Christian. We talked a lot about good solution based on open source. We have seen a different open source work together. What's your impression? Can we claim that we convinced the energy sector that this is the way to go, or do you see still major roadblocks in making this the say standard approach? What's your feeling at this point? Are we there yet?
I don't think we have to convince. I don't think we have to convince anyone, honestly, because this is sort of happening by itself in a bottom-up approach. We already today have most of the production happening at the edge, so things need to change. And the other factor is that with this bottom-up approach, the market design we have today will no longer work. So I think the change will happen by itself, but it, of course, we can help it happening slightly faster.
And would like to get from Josep the impression you come mostly from a power electronics background, and you are the master of the microgrids. How was your experience using FIWARE? Was the application of FIWARE in that context easy? Was major effort? Did you see major point of major lacks, I would say, to make it happen in a large scale? What has been your experience in that direction?
Yes, I think that it has been a very good experience from the viewpoint that we can integrate massive data from many data sources, and taking into account also the demand side, the generation side, consumption side, and this allowed us to create, also together with the ICT infrastructure that we have in our living laboratories, a very good energy management system for our microgrids. Now what we see is that it's going to be very attractive to use also FIWARE to integrate multiple microgrid systems. So this way, not only we are inside the component level, but also, let's say, in a systems of systems level. And I can see that this is also the future when we talk, for instance, about peer-to-peer energy solutions and those things that I think that are coming.
Thank you.
Yeah.
Yeah, right. So I was trying to reach Hans-Peter, if I can do it, and ask him what was also his impression in the German market introducing open source solution for energy. If you could share what was the customer feeling about it.
First of all, before I give you my full answer, I'm fan of open source, I'm fan of FIWARE, and I think we are with the solution on the right track. But also on the other side of the coin, we must be aware that we have several really excellent and niche solutions. But to win the Main Street, maybe our tribes must be better aligned. When we integrate some of our solutions from a business perspective, the cost of ownership increased, because we are using different frameworks for integration, for staging, for quality management, and that it makes maybe hard for companies like local utilities to use such solutions, because in their data center, in their organization, rise the effort for system integration and operations. And maybe it would be one good idea to have more standardized platforms regarding, for example, DevOps, staging and testing in place, that our customer can accept our solution in a more feasible way. Also, it is important, if we have a focus on open source and best practices, that we use a language of best practices that other utilities can reuse it. I think until now, many providers, including ourselves, using a specific language and code fragments, which make it very difficult to reuse it. And if we want, as a community, be successful, maybe we should have an aligned framework picture in place, how we can offer and serve our solution in a faster way for the customer.
Thank you. Thank you for this very interesting insights. I would like to ask a question again. This is open to all the three members of the panel. We had a back and forth in terminology between microgrid and local energy community. What do we need to add to a microgrid in terms of IT solution to make it an energy community?
Yeah, I think this is a question for yourself, right? More.
I was trying to get some hint from you.
Okay. Yeah. Well, your question was about. Can you repeat again?
Yeah, we had, if you think about through the whole day, I mean, all day, the 2 hours of discussion, there was a back and forth of terminology between microgrid and local energy communities. So if we start as microgrid, which I think is a more technology-centered idea, what do we need from the IT perspective to make a microgrid become a citizen energy community? Is just one-to-one, or do we have something on top?
Well, it seems that it's both, no? Because it's not only one-to-one, of course, and because we know that when we are trying to build energy communities, especially if you think about the Scandinavian market, we need to interact with our DSOs, which are more and more prepared to have microgrids and also virtual power plants. So in that sense, yeah, it's both. It's one-to-one, but communication with our DSO, and it's also to have information about, for instance, our North Pole market to see how we can integrate it, and also I think it's very good to have also integration with smart meters. For instance, here in the Nordic countries, we have a lot of them with Knaust, which also are are very good not only to connect with the utility, but also there are some third parties in Denmark that already develop applications to use the smart meters locally. So this means that I can get the information from my smart meters and to use it to manage the energy system inside and outside. So I will say that this is really good to look at the different perspectives.
Yeah, this last point is a very interesting one. I think we are really here in Germany, for example, looking forward to the large deployment of the smart meter gateway and control box that will bring the smart meter in, exactly in the context you're talking about, which is currently not available in the German market. But that's supposed to be kind of the next step, which will hopefully open up the market of flexibility at a completely different level, which is a key element. Listening to all the numbers we gave this today about penetration of renewables in the last year, this is a key aspect that we are all waiting for. But time is the manager here.
Antonello, we actually have one question in the chat here, which I think we should address in the panel, because it's very, very relevant, I think. It is this energy transition. We have the big energy utility companies, and they need to change with the energy transition as the activity moves to the edge of the grid. And there seems to be some worry that how this is going to play out. And I think we have seen this very, very many times in history when we have these dramatic transitions. And companies who do adapt survive, and companies who do not, they disappear. So I think we have so strong forces here. I mean, me sitting here representing one of the biggest energy companies in Europe, they have to adapt, then they have to find new business models. But their part in the whole solution will remain for quite a while longer. I just wanted to make that comment because I think it's relevant.
Yeah, I think it is relevant. But I found your first answer very reassuring, because while you were saying those very open consideration about how the things are evolving, the fact that it was coming from you working for such a large corporation was maybe the best positive signal we could get in this election.
Well, I'm just one representative of 30,000 employees, so let's see.
Okay, we trust in you.
We're trying to wrap things up, are we?
Yeah, I think I should give back the microphone virtually. And thank you for joining this panel and contributing. And we move to the last point of the agenda, I would say.
Yeah. So let me try to conclude here. We are in an energy transition in quite a while, and we all agree on that we have the next 10 years to make this happen fully, to go 100% green. And today we have seen many aspects of this transition, not only technical solutions, but also the legal aspects and the human factor, which is very important in this. There are certain things we know for sure. Future is always uncertain, but certain things we know for granted, and that is that the majority of energy production will come from the edge of the grid. The world of energy is indeed being put upside down. So all our efforts we have seen here today will come to use one way or another. And to make it really true, I think collaboration is key. Everyone represented here today can put their piece of the puzzle together, and if we want to succeed, we better collaborate. And with that, I would like to hand over to Christina.
Thank you very much, Christian, already for your summary. You anticipated many points I also wanted to underline, and I have to say it's just amazing the transformation the technology is showing, and consequently the market. Myself has spent many years in the energy business. I was also part of the acquisition when Siemens went into the meter business. So many of the things are still very familiar. Also, obviously, we are in a fully different generation of technology now, and that's very exciting. I thought we really made a super journey today, looking at what producers and distributors do and how technology can help there, up to the really end consumer, like each of us personally is, and what that could mean for us. And I have to say, it's very hard for an end user to get your head around what consummation really means unless you dig deep. Or, for example, myself, when I got my first solar roof on my house, you suddenly learn what it means each sunny day or not sunny day to your energy bill. So I'm very happy to see that also we had a little bit the discussion about how consumers' behavior can be changed or adopted. I thought also the controversial comments we got between Anna and Ulrike was quite interesting. I also want to just refer to the great material that many of you have placed here and put into the chat. I tried to contribute to that with some FIWARE material. I'm sure we will be able to share a bit more, and most of the presentations and links can be anyway found in the registered session then on the YouTube channel of FIWARE after today's live session. Yeah, said that, I would say as some closing words here, open source has really a great potential for the energy sector. I think that this came out at the very end, and we heard also some numbers before. I need to find back my notes, but I think we saw the slide that says 40% of the efforts of decarbonization will be open source. And thanks for the comment from Shuli from Linux Foundation. So said that, also FIWARE plays its role here and can address the energy sector's demand for digitalization really well, providing a standard way for solution providers, and also develop and integrate their smart energy solutions. And yeah, I think it was a very round journey we did today. And thank you for providing all these insights from high level to real detailed use cases. Thank you so much for the speakers who contributed to this. And also, by the way, thank you to our great business and press supporters, media partners, as business reporters, Citizens Forum, Compass List, our Future Water, and soon Global Cities. We also have a quick look at what's upcoming and what we can still offer. And let me just jump back here to the slides. Okay, so we by the way run also already for a year or so a pretty nice booklet, which is our climate booklet, or Fighting Climate Change with FIWARE. You can all contribute to this, and this is why we're showing it. This is a booklet that really changed or gave the chance to bring your solutions to a wider and global platform. We launched it as part of COP25 last year, or actually already a little bit more than a year ago. We are heading version 5. And you can really make yourself forward and be part of it. There's already more than 30 FIWARE-based solutions in it, and we're obviously striving to make it more. This is all for contributing also and give a voice to the market around climate change, open source, and FIWARE. Yeah, and I think we have here, yeah, thank you very much for that slide. All the links that you may need to learn more or dig a little bit deeper when it comes to FIWARE, and obviously also good contacts if you have questions. Said that, thank you very much, and I would give the closing word to our fantastic moderator Christian and our yeah, one of our most beloved partner and supporter with Gianluca for the final words. Thank you.
Thank you all very much. Thanks all the participants. Let's do this soon again.